In this video, we're going to do another example of using transformations to sketch a graph. So let's say we want to get a sketch of the graph of f of x is equal to the square root of negative 2x plus 4 plus 2 on the end. So the base graph that we'll use here will be the graph y equals square root of x, because that's the main function that we see. So remember, for square root, we start at 0, 0. I'm going to make my scale a little bit bigger so we can see things a little bit better. I'm going to make every 2 units a 1, a 2, a 3, and so on. A 1, a 2, a 3, and so on. All right, so our base graph is square root of x, so we know we go through the point 0, 0, 1, 1. 4 is off over here, so 4, 2 would be another point, and we've got this half of a parabola that opens to the right. So this is the base graph we're going to start from, and this is the one that we're going to transform into the graph of y equals f of x. There are 4 transformations that we actually see here that we have to handle. I see a negative, and that always tells us that we're going to do a reflection of some kind. I see a 2 multiplied by something, so that means that we're going to do a stretch or a compression. I see a plus 4, so that's some sort of a shift. And I see a plus 2, so that's some form of another shift. The negative, the 2, and the 4 are under the radical. They are inside the function. Since these are on the inside of the function, they're going to affect the x, the horizontal direction. This plus 2 is on the outside, so it will affect the y, or the vertical direction. I always handle my transformations in order from left to right as I see them, as it's written this way. So the first transformation we see is that we want to reflect across the y-axis. We know what's across the y-axis because, again, this negative is indicating a reflection. It affects the x's, which means we have to go with the x direction to reflect, which is across the y-axis. So just doing the mirror image, we change colors here real quick. We get this point, and we get this point that's way over here, and we have a graph that looks like so. All right, the next transformation we see is that 2 times the x. So that's a horizontal either stretch or compression. And remember that we end up compressing when the number is bigger than 1 and stretching when the number is less than 1. The easy way to remember this is to divide all of your x coordinates by this constant. Ignore the negative sign, but divide all the x coordinates by that constant. So our next step here will be to divide all the x's by 2. The easy way to do that, again, is just to change the scale on our graph. Just divide the scale by the 2. So instead of having a 1, we'll have a 1/2. Instead of having a 2, we'll have a 2/2 or 1. Instead of having a 3, we'll have a 3/2. Instead of having a 4, we'll have a 2. And do the same thing here. That gives us our scale change for the x's. The next thing we see is this plus 4. We're going to do some sort of a horizontal shift. The easy way to do that is to set that equal to 0 and solve for x. The inside equal to 0, what's inside the function. We get x is equal to 2. Since the number is positive, it goes to the right. So we're going to go 2 units to the right. I should write shift 2 units to the right. A little difficult to do on this graph because I made my two-way over here. But we've got this graph all the way here. It's going to go, this point is going to go to, let me change my color. This point is going to go 2 units to the right, so here. This point is going to go 2 units to the right, so here. Oh, hey, sorry, that's not where that goes. Well, no, that's right. 2 units to the right is all the way over to here. My 3/2 is actually right there, so it goes right here. This point over here goes 2 units to the right, so that should be on the y-axis. So that's this next step. Finally, we've got the +2 on the end. That's going to affect the y coordinates because it's outside the function. And since it's positive, we're going to shift 2 units up. So this point's going to go up to here. This point's going to go up to here. This point's going to go up to here. And then this will be our final graph. Again, on these, I'm not looking for perfection. I'm looking for that you understand how to do the transformations.